this is Mr. T with a tutorial on solving and graphing absolute value inequalities. Shown here in blue, I have a very simple inequality that we'll start with, and let's explore what this means. Again, remember these absolute value bars or symbols, what they do, whatever number we have for x, it's going to make it positive. So if we check on the number line, which of the numbers make this true? Let's start maybe in the middle. Is the absolute value of 0 less than 5? Well, absolute value of 0 is 0, and 0 is less than 5, so that number works. Let's try 1. Absolute value of 1 is less than 5. Absolute value of 2, 3, 4. Now here this is 5. Is the absolute value of 5 less than 5? Well, no, they're equal, so that does not work. Absolute value of 6, that's bigger, so that doesn't work. And none of these would work over here. Let's look at negative numbers. The absolute value of negative 1 would be positive 1, but 1 is less than 5. Negative 2, absolute value would be positive 2, that's less than 5. This would become positive 3, less than 5. Positive 4, less than 5. Now this would be the absolute value of negative 5 would be positive 5, that's equal, so that does not work. Let's try negative 6. Well, the absolute value of negative 6 would be positive 6, and positive 6 is not less than 5. And we could see none of these numbers over here would work. Now, I only looked at the integers, but we could do the same thing with these decimal values in between. So if we graph this using inequality symbols, 5 did not include, and negative 5, but all the numbers between solve, so we would color in this part of the number line, and we have graphed the solution to this inequality here. Now if you remember from our unit on inequalities, what kind of inequality graph does this look like when we have what I call a barbell here? Well, if you remember, this is the inequality or the graph of a compound inequality that is of the type and. If we were writing a compound inequality for this graph, ignoring what we did over here, we would say that x is between 5 and negative 5. So this inequality and this inequality are equivalent. So we're going to use this fact that an absolute value of an expression less than 5 or less than something, a number, is really equivalent to a compound and inequality, and our way of graphing and solving these will be to rewrite our inequality as a compound inequality. Okay, I have cleared the screen and put a new problem on the board. Here we have x minus 3 in between the absolute value. So here we have an expression. The absolute value of an expression is less than 5. Well, we know from our previous investigation that this is equivalent to this expression being between 5 and negative 5. And we learned in our unit on compound inequalities of how to solve this. We want to isolate the x by itself in the middle. So to get the x by itself, we would add 3. And on a and inequality, whatever we do to the middle, we have to do to both ends of the inequality. And we get here negative 5 plus 3 is negative 2. Here we get x, and we get 8. And if we wanted to draw the graph of that, we would put a open circle at negative 2 and a open circle at 8. And since it's in between, the x is in between, we would highlight this part in between. So the values of x going from negative 2, just bigger than negative 2, and just smaller than 8 make this inequality true. Again, I've cleaned up the screen and put another problem on here. This time we have something added or subtracted to the absolute value. So on solving these types of inequalities, we always want to get the expression that's inside the absolute value by itself before we convert it to a compound inequality. So we're going to move this 4 to the other side by adding its opposite, and we get the absolute value of x minus 3 is less than 9. And now we can do what we've been doing on these problems when we have the expression absolute value less than a number, is we will turn it into a compound inequality. So we know that x minus 3 must be between positive 9 and negative 9. This time we're using 9 because we have this number here. Again, we will solve that inequality by getting the x by itself in the middle, and we get this compound inequality expression. And if we wanted to graph that, we would put a open circle on negative 6, a open circle on 12, and connect. Again, this is showing that all these numbers on the number line under this line make this expression here true, which then makes this true, which makes this true, and then goes back and solves our original problem. Okay, now we're going to look at, so far all the ones we've looked at, we've had absolute value less than a number. So let's look at what if this happened to be a greater than. Okay, so now I've written a very simple problem. So let's look at the number line. What numbers on the number line will make this true? Well, for positive numbers, the value 6 is, the absolute value of positive 6 is 6. That's greater than 5. That solves it. We're here. These numbers will all make that true. The absolute value of 5 is 5. That's not greater than 5. That's not true. 4 is not greater than 5. So these numbers do not make it true. 0 would not make it true. If we look on this side, if we take the absolute value of these numbers, say for example 3, that would be positive 3. That's not bigger than 5. When we get to 5, those are equal, so that does not make this inequality true. So let's look at negative 6. The absolute value of negative 6 would be positive 6, which is bigger than 5. So these numbers here. So if we drew a graph, we would have the boundary here is at 5, and the numbers out this direction make it true, and the numbers in this direction. You may remember from our discussion on compound inequalities, we could write an inequality for this. If we write this first part here, well, let's do this part here. It's going to be x is greater than 5, and this part is x less than negative 5, and both of these, if either of these conditions are true, our thing is true. So this is a compound inequality of the OR type. So when we go to solve our absolute value inequalities that are greater than, we will be turning them into a inequality of the compound OR type. Okay, we have a more complicated problem now. I skipped over sort of the intermediate problem to go kind of to the final problem here. Remember when we did the less than, we wanted to start out getting the absolute value expression by itself. So before we interpret this, we're going to add 4 to both sides. And we just said that when we have a greater than symbol, that is equivalent in compound inequalities to an OR. And we know that we're going to have this expression bigger than positive 9, or we're going to have that expression smaller than the negative of that number, negative 9. So now if you remember from compound inequalities, we just solve each one separately. So we get x less than negative 6, or in here we get x greater than 12. And on OR problems, we just graph each of the inequalities separately, because if either inequality is true, the compound inequality is true. Remember, for AND, it has to make both inequalities true. So this would be our graph for this absolute value inequality. So what we've learned here is that we will be converting absolute value inequalities to compound inequalities, and if we have the absolute value of an expression less than a number, we are going to turn that into a and or in between inequality, and we will do that by putting the expression between the original number here and negative of that number. And if there had been anything added or subtracted to the absolute value, we would have converted that to the other side before we solve. And secondly, if we have absolute value of an expression that is bigger than a number, greater than a number, that becomes a compound or. Well, let's just move that straight down here. So this symbol here means or. And remember, we could have the expression bigger than our number, or our expression could be smaller than the negative of our number. So again, just to finalize here, the whole key on these absolute value inequalities is to convert them to the appropriate type of compound inequality. Absolute value less than becomes an and problem or an in-between problem, and greater than becomes an or. I hope this helps, and have a great day.